Hey, Healthcare Universe. It's Hank Balch here from Beyond Clean. And today we're going to be talking about UV disinfection in the operating room and sterile processing space, in addition to a few other applications out there. But in particular, we're going to talk about the basics of the technology. What is UVC disinfection? How does it work? What are some misconceptions? Where is the industry going? What does regulation look like? All those types of topics and more on the show today. What I want to ask you to do, if you're tuning in today from Facebook, LinkedIn, or the YouTube feed, is please comment in the comment section below and let us know where you're watching from, and let us know the questions that you have for the panelists today that are on the show with me. So speaking of panelists, let me bring these guys in here to join us. Gunnar Lyslo is joining us, in addition to Jeremy Starkweather. And I'm going to let these guys introduce themselves, tell a little bit about your background, Gunnar, how you got into the UVC industry, and then we'll hand it over to Jeremy, and then we'll get started with some of the questions. Sure.
Well, thanks, Hank, for the opportunity, and good afternoon, everybody. I'm looking forward to a really exciting conversation. So I'm the founder and CEO of Surfacide. Company was founded back in 2010. We spent a significant amount of time on R&D in the early years, and then kind of went through a process of a slow launch, and then into full commercialization. I guess I got into the UV space actually as an outcome of my experience that was originally in the water space, in which we were developing technology that was being used by hospitals to disinfect hot water distribution systems. But as part of that, I also had some experience in the use of UVC as a disinfection modality. Really back in 2010, then was the emergence of all the multi-drug resistant pathogens. Primarily back then was MRSA, and it all kind of evolved from there to, not only all the MDROs that we're dealing with, but then now we're in the midst of this pandemic. So that's really kind of all hands on deck right now of using UVC as a modality. And like I said, I'm really looking forward to having a really active and engaging conversation with the audience. Awesome. Yeah. Welcome to the panel. So Jeremy, what about you?
Yeah, thanks, Hank, for the invitation. And I also look forward to talking to your audience today and having a robust discussion with the questions coming in, and with Gunnar and yourself. So my background is medical device. I've been in the medical device space for about 20 years. I spent plenty of time in the OR. I understand sterile processing. And in 2016, co-founded UV Concepts, because there was just a clear clinical need in the peer-reviewed publications that portable medical equipment was not didn't have adequate disinfecting processes. Primarily non-critical medical equipment, but now we're seeing even medical equipment such as interventional and diagnostic equipment that also harbors pathogens. So we developed the concept of an ultraviolet enclosure over the past 4.5 to 5 years. We launched pre-pandemic back in November with our final technology, and the timing is quite remarkable. As the pandemic hit, and a lot more notice is being paid attention to all surfaces in the hospital space, or not even just the hospital space, in all healthcare. So look forward to uncovering what myths might be out there, and hopefully we can provide some clarity. So thank you for having me.
Awesome. Yeah, I think that the topic of the pandemic is going to come up a couple of times in this conversation, and the impact it has had on the industry and the technology in particular. I want to welcome everyone who is still jumping on the stream here. As you see below, we got an audience poll to put in where you're watching from. We'd love to know if you're tuning in from the United States, from overseas, and in particular, we want to know the questions that you have about UVC disinfection in the operating room and sterile processing space. And in addition to that, we got another poll here that I'd like to get your insight around. If your hospital or facility, ambulatory surgery center, is already using UV technology in some capacity. So if you're tuning in from the operating room, from environmental services, from facilities management, is there some type of UV technology in your facility today? Let us know what it is, or if you don't know what it is, let us know what you're disinfecting with the technology. To kick us off here, and I've told both of you guys this in the pre-setup for this panel discussion, I don't know a lot about UV technology. I am in the medical device reprocessing space, so I'm very familiar with cleaning and disinfection, high-level disinfection and sterilization, but not too familiar at all with the impact that UV has on the cleaning disinfection process. So as we get started off here, I would like to work on some basic definitions and concepts for UV technology. So if you met me on the street, Gunnar, and I came up to you and said, hey, I heard you're in this industry. I heard that you make these types of lights out there that kill bugs and microbes, but how does it work? How would you respond to that?
Yeah, so that's a really good place to start. So if I were to meet you on the street or in the elevator, I would indicate that we're really in the decontamination. So when we're using UVC as a wavelength of energy, we're decontaminating those surfaces that are within the direct line of sight and are within a distance proximity that allows us to deliver an effective dose. Essentially what's going on though is that we're delivering energy in the invisible light spectrum, which is 254 nanometers. And I don't want to bore everybody to tears with some of the minutia and those details. But it just so happens that particular wavelength of energy is very effective against bacteria, virus, and spore. And so there are plenty of data in the peer review forum to indicate, how effective that is. But in delivering that energy onto those surfaces that are within the direct line of sight, we can see, significant reductions of that bioburden. And it's being used extensively now throughout hospitals. Now, as a result of the pandemic, it's being used in other verticals, with really some great success.
So it sounds like line of sight then, Jeremy, is an important part of this. And I've even heard that, the limited information that I know, line of sight seems to be a big deal. And to that, I'm assuming that there's other types of definitions, that come in to play besides just the technology itself. So what are those other secondary things that you need to be aware of as you're thinking about UV technology and how it works or how it should work properly, that'll be important to kind of set out at the beginning of this conversation?
Yeah, so one of the things that you have to consider is the intensity of the lamps that are delivering the UVC in the proximity, including the line of sight. And that intensity and proximity in layman's terms gives you a dosage of energy, and different pathogens react to different dosages. Spores require a slightly higher dose of UVC energy to kill than a simple virus. And reputable companies in the UV space should have a good idea of what dosage is required to inactivate pathogens. So that proximity, that intensity brings everything together. I do want to mention that UVC's effectiveness diminishes in the presence of soil. We do test in the microbiology lab let's call it a soil inside mixed with the pathogen to see how effective you can be in a soiled environment. But standard cleaning and disinfecting with a wipe down and the soil removal should be done prior to the delivery of the energy and the UVC. So
that's a really important point. What Jeremy was just saying is, the use of UVC as a modality is adjunctive to, other cleaning processes. So for your audience or for those that are considering the use of this technology, we are not eliminating, or when we are talking with a healthcare provider, we're not even remotely asking them to consider relaxing those other cleaning processes. So whether that's with bleach or with a quat, just good old fashioned, elbow grease. We're really the cherry on top. But the data, which is really probably surprising for a lot of the people in this call, is that, as hard as those in environmental services are working on a daily basis, the data in the peer review form show that upwards of 50% of surfaces remain colonized with bacteria after a terminal discharge cleaning. And terminal discharge cleaning, it really kind of, for all intents and purposes, that's a nomenclature that hospitals use, but that's kind of like that floor to ceiling cleaning. So imagine if you're going to enter a hospital room and you go in knowing that 50%, one half of those surfaces have not been cleaned. So that's when I refer to the surface side technology or any UVC technology as really being adjunctive or the cherry on top. We're just going to capture all those surfaces that were missed by the hard work of the environmental services team.
Yeah, Hank, I'd like to add on to that. This is no different than what you see in sterile processing departments. They're going to go through a washer prior to going through a sterilization unit, or if you're doing an endoscope, you're going to go remove soil with a brush immediately post-procedure, remove the soil prior to, and you can use it as enzymatic detergent possibly before you go into a high-level disinfecting process. It is interesting when you do the culturing on surfaces, to add to Gunner's point. Surface sides technologies is focused a lot on rooms. UV Concepts technology is focused a lot on portable medical equipment. But if you culture this equipment, they are contaminated, and sole reliance on a manual process, it needs additions to mitigate the risk. You could have anywhere from 30 to 50% of surfaces on portable medical equipment still contaminated after the wipe down process. That's what we've seen also, that matches up with the evidence that Gunner just alluded to.
Yeah, I don't think there's going to be any audience that is quite as in tune with this idea of, if it's not clean, it can't be disinfected, or in a sterile processing space, we often say if it's not clean, then it cannot be sterilized. So that aspect of, the balance of soil removal plus the application of, whatever it is, if it's UV technology, if it's gas, if it's additional chemical, that concept, it doesn't change depending on what technology you're using. You still have to start at the basic level of science, right? How do we get something clean, and then how do we move something from the definition of clean to whatever the definition of disinfected is?
Sure.
And in fact, let's maybe stop there and talk about, in this industry, in the UVC industry, when we hear the words that this is a disinfection unit, or we disinfect if it's a room or a wheelchair, what does that mean? Is there an industry standard? I know about the 6 log reduction, as the goal, but is there a spectrum in there that anybody can claim disinfection from this level up to this level?
Yeah, I'm happy to take that. That is an area of controversy even amongst the UVC community. So the FDA and the EPA have not been crystal clear on that. We've approached the FDA. We've talked to the FDA, talked to them about a low-level disinfection claim. And they had mentioned, hey, here are the viruses and the bacteria that you need to disinfect at a 6 log level. But that might not be as clinically relevant as you would think for these surfaces. I think there needs to become a consensus and an agreement amongst regulatory bodies and the UVC community that you can have a more safe surface even in the 3 to 4 log reduction level, and you should broaden the pathogens that would historically be looked at from an FDA washer disinfecting technology that doesn't include spores. So the low-level disinfection claim doesn't include spores, yet there is a study that showed that anywhere from 30 to 47% of surfaces on a wheelchair have C. difficile spores on them. So how are you going against that? And what's the dosage needed to do against that? That is what really needs to be figured out here. There was a conference earlier this year. Gunner and I were both a part of it at NIST, which is National Institute for Standards and Technology. part of the U.S. Department of Commerce, and it was leaders in the UVC space. It included FDA and EPA. I hope that that was the start of that conversation that's a little bit more in depth, because we really do need to have better guidelines as we move forward. But a lot of epidemiologists, a lot of infection prevention and control experts would say that in a 3 to 4 log reduction, you are significantly mitigating risk.
Do you agree or disagree, Gunnar? What's your insight on that?
I do, and it's for that reason the nomenclature we use when describing our modality is decontamination. Disinfection, suggests, a 6 log reduction. And to Jeremy's point, there's kind of the bench world, but then there's the real and practical world. And I've had numerous conversations with infectious disease docs or epidemiologists, and their comments to me is, if you're walking into a patient environment where you have 6 log of anything, you've got really, really big problems. So, for us to be able to demonstrate, a 3 or a 4 or a 5 log, reduction, which we have numerous data supporting that, we just think that it's really important to be very transparent. And I think that's one of the real advantages of having a conversation like this is just put all the cards out on the table. While yes, we can achieve 6 log reduction of all of these, very clinically relevant pathogens, when we're going into an environment, we're describing it as a decontamination event. And so that includes vegetative bacteria, that includes spore, and that would also include virus.
Right. Now, both of you guys are selling into the healthcare space in addition, to other areas out there. I'm curious, the conversations that you have with either environmental service directors, facility managers, infection preventionists about these technologies. What are the most common myths and misconceptions, if you will, from the purchasers of these devices or potential purchasers, but also from the users, the folks on the front line that are either setting up the equipment in the rooms or running the equipment through the UV equipment that's provided? And I guess, Gunnar, if you can speak to that question first.
Yeah, so I think it's also a really good question. The paradigm shift in using UVC as a modality is understanding that, it's leveraging simple engineering principles, or more specifically, simple laws of physics. And so the paradigm shift is most of us have familiarity with, the chemistry. So whether that's bleach or quats, or how an environmental services team or a housekeeper or somebody in the janitorial space is coming in and cleaning that surface. But it's just so important to recognize that there's really not some magic fairy that's going to come in with magic fairy dust, to capture all those surfaces that are not coming in contact with the energy. And so an analogy I like to use, Hank, is let's just use bleach. If I'm a housekeeper or an environmental services team member, and I come in and I wipe down one bed rail with bleach, and I miss the other bed rail, so the other bed rail is not cleaned, well, one would presume that that particular bed rail will remain colonized with bacteria. And the same is true with UVC. There's nothing magic about it. And so what Surfacide did, and this is where our intellectual property comes into the mix, is that we use the multiple emitters. So you can see those actually in the background. I just happen to be here at our global training center. But with the multiple emitters, by creating a triangular configuration, whether it's around a bed or whether it's in a hotel or a restaurant, for the vast majority, those surfaces are within the direct line of sight. But then equally important, they're very close in proximity to our emitters, which therefore allows us to deliver more energy in less time. And the physics element to that is the inverse square law. So what that law tells us is that as the distance doubles, the energy is reduced to a quarter of the power, not 1/2. And so quite candidly, one of the alarming things that I'm seeing right now is that we're seeing a significant number of new market entrants that are promoting their technologies on Amazon and throughout social media, and they bring in a very small device and they say, we can bring in this device and we'll disinfect an entire gymnasium. Well, unfortunately, that's just utter nonsense. It just doesn't work that way. So, if it sounds too good to be true, it likely is too good to be true. And so I think that when you're contemplating, this is a modality and you're going through your due diligence process, rely on the data, trust the data to identify, is this a technology that has proven itself in whatever application that it is that, you're considering. But it's pretty easy. It's shadows and distance.
So just, because I'm curious now with the gymnasium point. So in terms of physics, like, could you, if you had, 50 years to disinfect, if you set one of those little units in the middle and it was just emitting, like, is it because there's not enough time, or does it go into the dosing and the distance that you've mentioned a couple of times?
Yeah, so it's a pretty simple formula, and I'm going to oversimplify it, but it's time plus distance equals total delivered energy. And so using your example, Hank, is that, yes, if you brought in an emitter and you had hours and hours or days or weeks or months that you positioned at center court, over time, the dose the dose is cumulative, so we would eventually deliver an effective dose that would likely, reduce the presence of the bioburden at X number of feet or meters away. But in the real world, we just don't have those types of times. And so whether I'm in a hospital or a hotel room, or, another great customer of ours recently is the Seattle Space Needle, businesses and entrepreneurs just don't have the luxury of that time. And so for our own purposes, and I have a little bit of a bias here, but for our own purposes, by bringing in multiple emitters, that's how we get across the goal line. We can deliver a very effective dose of energy in significantly less time. And what that then also allows us to do is it allows us to craft more disinfection cycles or more treatment events. And so if I can touch more hotel rooms, or if I can touch more rooms in the bone marrow transplant, that's what it's all about. And so Jeremy is also with this technology, and I'll throw it over to you, but kind of a very similar concept, and I don't want to put words in your mouth, Jeremy, but because you've got that enclosure, you're very close in proximity to the wheelchair in which you guys were really concerned about. So that's how you guys cross the goal line, because you're introducing energy for all intents and purposes to the entire wheelchair that's in your device.
Yeah, and we do it at a very close proximity. The unit is big enough to accept a wide variety of pieces of equipment, but it's small enough to deliver a very, very intense dosage, which allows you to have a 60-second cycle time. Getting to Hank's questions about myth and misconceptions, it is interesting, UV Concepts, we are starting to find ourselves dealing with a lot of different departments. So where you typically only deal with environmental services, when we deal with a lot of them, portable medical equipment is a completely different environment. You have nurses in different wards, whether it's the ICU or the burn or transplant. You could have a volunteer staff. You could have folks in the OR. Portable medical equipment, which rolls all over the hospital, has a lot of different stakeholders. And those all typically have different training when it comes to how to clean and disinfect, or to Gunner's terminology, decontaminate these surfaces. So we have to do a lot of education to the folks who might not use UVC on a day-to-day basis. And that education is, hey, you got to remove visible soil. But then they will say, oh, can I, what about all the nooks and crannies? Well, to our point earlier about line of sight, you're not going to get into some far-reaching nook and cranny. But let's talk about what's important. These surfaces in a hospital environment carry the same risk of being a vector transmission as a hand. If you have a dirty hand and you have a dirty surface, they can carry the same risk if a pathogen is on that hand or on that surface. That's the way the high-touch surfaces need to be looked at in the healthcare environment. What's the likelihood that surface is going to touch a hand, going to touch a visitor, going to touch a patient? You need to think about a higher level of decontamination or disinfection of that surface. So do you need to get in some nook or cranny where no hand is physically possible to get? I don't think so. Do you need to do what's clinically relevant? And that is a high touch surface. I think that's important. And so how do you do that? If you look at the cleaning and disinfecting process that is today, you don't see You don't see technicians flipping ultrasound machines on their side and cleaning the bottom of it because it's not a clinically relevant surface. So that's our focus. What is a high likelihood touch surface? Is it a shared piece of equipment? Does it move from a COVID positive room to another inpatient's room in the same day? What are you doing from that moment in time to the time it goes to the next patient? That all has to be considered. But as we find ourselves broadening our call points within the hospital, we are finding ourselves having to really do a good explanation of what the technology does, why you need it, and how it should be used on a day-to-day basis.
And, Hank, maybe I could jump in. I have slightly different, perspective. And while I agree with everything that you're saying from the perspective of high touch, in this new normal, and unfortunately we are all living in this new normal, every surface becomes incredibly important. And so to his point, that it just takes that one particular surface that may have been touched or may have been touched by a COVID-19 positive individual, and that they're just positive, asymptomatic or not, but then I happen to come in, and that may not be truly considered high touch. Like a lot of times when we're talking about high touch, it's like a light switch, a door handle, the elevator buttons. But in the healthcare vertical or in other spaces, if it's a restaurant or if it's a hotel, just think about all of those surfaces that could be missed by, the environmental services team. And so we really try to focus on the entire space as being critically important, because what I do agree with Jeremy on is that all it takes is that one touch where now my hand is colonized and I'm going to touch my eye or my nose, and then it's kind of like there's a high probability that I will now be, colonized. So we really look at the entire space as very, very critical.
Good point, Gunnar. And I'd like to disagree with you, but I agree.
So, yeah, you'll save those disagreements for later. It's coming up. No. So a question, for the audience, we got a lot of folks tuning in now. And as you've seen some of the locations, from across the globe, from India to South Africa, even out to Washington State, all the way out there to Washington State. So the question I like to ask, for the folks who are tuning in right now, or if you're watching this afterwards on demand, is if you have the option as a patient, like many of the folks in the audience have been patients. I've been a patient, had my appendix taken out a couple of years ago, and it was, one of those experiences where the clinician turns into the patient and too much. So I'm going into this procedure and I know all the things that could happen. And the nice nurse came in and said, oh, it's going to be fine. We do this laparoscopically now, tiny little incisions. And I'm like, well, yeah, that is good. But I also know the downside for laparoscopic procedures. And so like my mind is racing. So as an audience member, right now, hearing what you have heard so far in the panel discussion, whether or not you had background in UVC technology or not, if you had the preference going into a hospital room or putting one of your loved ones in a wheelchair, and the option, today is some type of manual wipe down process, or that, or UVC technology, and whatever kind of application it is, as long as it's up to the right dose, which we're going to talk about here next, would you prefer to have that for your loved one? That's the question. I'd kind of like to see your answers in the comments here. Would you prefer to have UV technology applied to your devices in your rooms or not? Because at the end of the day, yes, we're calling on hospitals, we got decision makers, we got cost, but it should come down to the patient. What does the patient want, and what's the patient asking for? And there's all kinds of debates happening now in the medical device space around different modalities for processing, different single-use instrument options, and I'm of the opinion, again, that, yeah, it's important for these folks to make business decisions, but the business is the patient, or the business is the customer in the hotel, or the child in the schoolroom, right? So those should be driving that. So I'd love to hear from the folks in the comment section below, if you can let me know. To move on, as I alluded to a second ago, we're going to talk about dosing issues, and this has come up, off and on so far in the panel, but I'd like to speak a little more specifically to it, to what is the concern around dosing, and the same, the corollary to that, especially for users of these devices and equipment, is what about indicators? How do we know that the dose that you say is being provided from this unit is actually occurring? How are those things measured? And I guess who's up next? Gunnar, do you want to take this one first?
Well, hey, validation, right? Validation, validation, validation. So with our particular technology, we have a laser mapping technology that measures the distance, and then that drops into an algorithm, so we're delivering the effective dose. But we're also using the dosimeters to validate that the effective dose has been delivered. And I would encourage anybody. So for the audience, if you're looking at any technology, bring that simple dosimeter in, because like President Reagan once said, trust but validate. And so, all right, trust everything I'm saying, but then validate it. And if I can't validate it using that dosimeter, it's like an SPD, right? When you guys are disinfecting the surgical instruments, this is not my area of expertise, but if I understand correctly, you put that in there and there is a coupon that will indicate that the effective chemical dose was applied. And if that indicator doesn't turn, you rerun that cycle. And so, Hank, I think that's right in your wheelhouse. The same could be true, in the use of UVC, whether that's in a bone marrow transplant unit or whether that's in a dentist office. We got some great dental offices that are coming in. We just put one in at Renew Dental in Phoenix. Kind of a really great, proactive measure. But yeah, they're validating the use of that technology. It's just really, really important.
So, Jeremy, can you speak to that perspective around the dosimeter? And I don't know actually if we've defined what that is. So, like maybe just tell us what that is, and then in your context, because you're not talking about rooms, you're talking about equipment. How is that measured?
Yeah. So, dosimeter is basically a chemical indicator that changes by the amount of 254 wavelength, or they can even have the ability to make them in other wavelengths. The most common one now is made by a company called Intelligo out of Europe, and they make a very nice product, and they can even modify that dosimeter. But it really should come down to the individual company's technology and methods, and being able to validate to you that they are reaching the appropriate doses based on whatever claims they are making. So we have a slightly different environment than Gunnar does, even though we are starting to explore and we are ready to roll out dosimeters to our customers. But because we're in an enclosed environment, our distance never changes. So when we are doing our microbiology testing, we measure the dose in the center of the unit at the site that we're doing the pathogen kill. So we know the different regions of our enclosure. We know the dosage delivered. We know that at 20 seconds, 40 seconds, 60 seconds, all the way out to 5 minutes. And we consider that furthest distance in which we do our microbiology testing to be kind of our standard dose. Anything closer to the lamps is going to get even a higher dose and should have effective pathogen kill. So whether you are dealing with Gunnar's technology with Surficide, and they have their mechanism of validating dosage, we have a method of validating our dosage, and then we can periodically do additional validation with radiometers and dosimeters. We also monitor the performance of the lamps throughout every cycle. We do that remotely with every unit that is deployed into the field. So we have an accurate dose. Anybody, and I would say this to anybody in the healthcare space, anybody that is considering acquiring a UVC technology, that company should be able to tell you what dose is needed to kill pathogens with their equipment, and they should be able to tell you how they've done that and how they'll do that in the future. And I think dosimeter paper, these cards, are going to be really valuable in the future and right now.
Yeah, agreed. And I don't want to hurt any of the feelings of the microbiologists if there's any that are in the audience here. But the gold standard also, Hank, is live culture. And so it's not nearly as expeditious as the dosimeter, but we worked with, so we're in 500 hospitals. Numerous hospitals will do these spot checks where they'll literally go in with a sterile culturette. It's like a really large Q-tip, and they'll swab the bed rails, they'll swab the tray tables, all that kind of stuff, and then they'll grow it out. And it's very, very problematic that if you are culturing after whatever decontamination, whatever technology it is that you're using, if you see high levels of growth, that's indicative of you have not delivered an effective dose. So again, I go back to what I was saying, trust but validate.
Yeah, that was a great interview.
I just want to reiterate to anybody that's in the space that is considering UV technologies, if your manufacturer of that product box is not open with their data, you should look to go somewhere else, period.
Yeah, no, I think that's good practice in general, whether you're buying a car or whether you're buying UV technology. So that's a great reminder. I was going to say about the culture piece. We did an interview on the Beyond Clean podcast with Dr. Christine Green a couple of seasons ago, and actually had that conversation in the context of ATP testing. But the argument at that point was around surfaces and floors in particular. The need to really be sampling those floors, to really understand what's happening during this process. And I think, we've got a lot of work in general to do in healthcare in particular. And I wanted to clarify, for myself, but also for the audience, if anyone else has this question, there's not a requirement out there from any agency or anyone to use any dosimeters or any indicators, or is there? Is that something that y'all have heard about from the Joint Commission or DNV surveyors? Is anybody out there in the healthcare setting who's using these devices? Is that something that they have to demonstrate at the moment? I understand the compliance piece, why you would want to, but is it required at this point?
Yeah, to my knowledge, Jeremy, it's not. There's not a requirement. It would really be at the option of the owners, whether it's a hospital or a hotel, to implement that validation strategy.
Yeah, to my knowledge, there is no requirement. I think it'd be good to have for the future, if not on every cycle ran, at least to make sure the technology is running correctly, even at a set period of time. We do that internally at UV Concepts, but there is no mandate. I do want to make sure that everybody knows that ATP testing is not an accurate predictor of pathogen kill with technologies like UVC. I've actually worked with Dr. Green. We actually had this conversation directly because you'll get bioluminescence even if the pathogen is completely inactivated, and post ATP won't give you an accurate reading. It will give you an accurate reading if you have soil on the surface, but with UVC, it doesn't truly tell you the risk associated with that surface because the pathogen could be inactivated and non-visible.
Right. That's a great point. So the next topic of conversation that I had actually has to do with material compatibility, and it goes in, to some of the newness of this technology, even though it's not brand new, but we're hearing more and more about it since the pandemic has rolled out, and it may be new, for some industries out there outside of healthcare even. But the question for a sterile processing guy like myself always is, well, was this device created to withstand UV dosing? So if it's a bed, if it's a wheelchair, if it's any other kind of device or structure that may be in an operating room, right? Have those things been designed intending to be disinfected with chemical, sterile, and wipe downs? And if they were not designed with UVC in mind, is that an issue in terms of compatibility? And I'll open this up to either one of y'all to go first if you have thoughts on that.
Yeah, so material degradation is something that we're continuously looking at. The one other thing that I would add to your question, Hank, is that one of the real serious consequences when it comes to disinfection is the use of bleach. And we know how harsh bleach is as a chemical. So, we will walk into a hospital or walk into another environment, and everything has been, bleached out, or you see cracking and those types of things on some of those surfaces that just, don't play nice in the sandbox with bleach. The thing that's pretty interesting about UVC as a modality is that one of its weaknesses is that it just doesn't penetrate stuff very well. Hence the reason we want to remove the bioburden. So just good old-fashioned elbow grease. One of the processes that we implement is prior to sending out any of our equipment, we have an 8-hour speed to failure test. So we have a pretty robust quality control as far as how that system is going to go out to the end user. And what we had done a couple of years ago is we took common materials, so plastics and all those things that you may see. And this was pre-pandemic, so our focus was primarily on hospitals, but the plastics, the TV remotes, all those types of things. And then we just simply wrapped them. So we used a tinfoil wrap, kind of half wrapped, half unwrapped. And we really didn't see any major or significant degradation. There was some very, very minor color adjustments, but it really took a lot of effort to kind of identify that, but you could see a little bit of a delineation, but it wasn't enough. And we share that. We're pretty transparent with, our customers. We share that with them, and they say, well, given the choice of doing nothing or bringing in the surface-side technology that has demonstrated efficacy, yada, 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 they tend to go with that. That all said, we are continuing to collaborate with our healthcare partners, and now with our partners outside of the healthcare vertical, just to learn more about how the UVC is interacting with a lot of those materials.
Right. Kat, what do you think, Jeremy? Got any insight on that? Are you working with manufacturers of wheelchairs to plan a little more proactively on their devices, or what's the plan around that?
We're actually constantly engaging with manufacturers of medical equipment. One of those happens to be we're in some early talks with a manufacturer of a wheelchair, and I hope to do some testing with them soon. And then also a manufacturer of a cardiac ultrasound machine, and they've done extensive material testing on all the different components. It is going to be tough for UVC companies alone to test every material used in medical devices. When I received the testing protocol from this cardiac ultrasound manufacturer, it was about 160 pages, and they had 50, 60 different types of materials. Mm-hmm. So I think that there is a level of collaboration that needs to be done with UVC companies and the manufacturers of medical equipment. That can be collaborative. I also think medical equipment manufacturers need to be thinking about, if UVC is going to be used in the environment that their equipment is going to be used, that they should also proactively do some things from a material aspect. Putting UV inhibitors in the materials that they build would be an example of something that a manufacturer could do. And I would think that a manufacturer would want to do this because even in an anecdotal sense, the material degradation of harsh chemicals is greater than UVC. And what we're doing at UV Concepts specifically is we are doing that material degradation testing, but we also want to control the dosage of UV that hits the surfaces. And then when you get to the correct pathogen kill, you shut off the cycle. So UVC disinfection, decontamination is not new. It's been used in air and water for a long time. It's been used in the healthcare space for over 10 years. So we're getting a reasonable amount of experience, and we feel we're pretty good. There's still a lot to learn. We don't know everything. We need to do more. Manufacturers of equipment need to do more. But I think we're moving in the right direction. We, like I mentioned, want to deliver the correct amount of dose at the right time. Don't overexpose. It's got a minimal depth of penetration, a good pathogen kill, and then your cycle's finished.
And Hank, I fully expect that other manufacturers across the entire ecosystem are likely going to be applying some of these UV inhibitory in this new normal. And I guess when you have lemons, let's make lemonade. In this new normal, I think it could be argued that just about everybody now has a far, far greater understanding and appreciation of infection prevention. And so whether that is in the healthcare space or whether that is in a movie theater, in the new normal, most people I'm talking to, it's on the back of their mind, how was this place disinfected, decontaminated, whatever nomenclature you want to use. And so as manufacturers recognize that they want to be able to provide materials that are going to result in safer environments, I think that they're going to come on board with that. So we've had numerous manufacturers reach out to us to try to get better understanding. We've actually done some kind of collaborative testing on just like, hey, is this going to work on this particular material? I mean, I think that what it's going to take is industry leaders to really collaborate with each other, knowing that, hey, it's all for the greater good. We're not competitors here. What is it that we can do to provide a safer environment, really a safer world? Because unfortunately, SARS-CoV-2 is not likely going to go anywhere. We may get the vaccine, may minimize things, but the likelihood that this is just going to disappear one day by the people that I'm talking to is just not likely. So as a result, we're just going to have to manage to that. And we will figure it out. Hey, societies have had to figure this out for a long time. But for those of you that may be doubting me, and I don't know what's going on in the chat room there, but hey, let's face it, like colds and flu, these are virus. It's not like when you get your flu shot, that you're never going to get the flu again. There's continuous mutations, and it's just a part of our world. It is now a part of the new normal. And as a result, there can be some pretty cool things because this just happens to be virus. I'm going to get off on a little side tangent here. Let us not forget that pre-pandemic, that there were numerous organisms that were multi-drug resistant. And as I mentioned early on, so back in 2010, the reason that I got into this space was MRSA, so methicillin resistant. My goodness, methicillin resistant staph right now is a cost of doing business. But the real bugs, like the carbapenem resistant Enterobacteriaceae, or hey, it was just 6 months ago, maybe a little bit more than that, when Dr. Bernard Kamens at Mount Sinai identified that, hey, C. auris, so Candida auris, which there really wasn't anything in the antibiotic pipeline that was out there. Mother Nature is going to continuously throw us curves. And so if we can learn from a situation like what SARS-CoV-2 or COVID-19 is presented, I think that we're going to be better off for it longer term. Yeah, it's not so much fun right now. I mean, who likes wearing masks? Who likes never being able to go out to a restaurant? Who doesn't like being able to associate with more of wherever it is you're living, 5 people, 15 people? I mean, it's getting lonely out there. We'll figure it out. We'll get through it. But I think the outcome is that companies are going to evolve and emerge to address the role of pathogens in the world, and we'll all be better for it.
Can we talk a little bit more about the superbug comment, because that's very applicable, obviously, to medical devices, operating room, sterile processing type folks, and that question and concern has been in the back of my mind too, with all the focus shifting, and we've even seen articles about it, how infection control in the healthcare setting has so pivoted to focus on the coronavirus that other surgical site infections, for instance, healthcare associated infections, are seeing a spike because their focus is elsewhere. And like, God bless them, not saying anything like that's too much for one person to handle, or even a small team to handle in these large facilities. But that question about the future of this technology, I think that's something that I definitely want to get out of this panel, is what are we looking forward to, maybe the next generation of this technology that can better address the challenges around superbugs, and in particular in that surgical setting, in the device setting. Do either one of y'all have any perspective or insights on that topic?
Well, yeah, I do. You're preaching to the choir, because as I had just said, Mother Nature is always going to be smarter than what tools we're currently providing. And so there will be the emergence. I mean, let's face it, Hank, we could have had this conversation, what was it, 2 or 3 years ago? Remember that little problem that we had with Ebola? You know, we were on the precipice of the world coming kind of to an end there. And I'm not even trying to exaggerate, but that was a very, very close call. And, you know, what is next? And I know for everybody in this conversation right now, I mean, don't shoot the messenger, but COVID-19, we're going to get that under control, but there's something else coming. Hopefully we get a little bit of a break, right? Hopefully it's not in 2021, but it will be coming. But that's one of the kind of cool things about using UVC as a modality is that, you know, over millions and millions and millions and millions of years, you know, organisms haven't encountered UVC. So, you know, the sun is producing UVC, but it's being kind of, you know, weeded out there by, you know, the atmosphere and the ozone. So this is all new. This is all very new to these organisms. And so that's where I like our chances as far as, you know, using this as a modality. Where Server-Side got a little lucky when it came to, you know, the novel coronavirus, which is now COVID-19. You know, a couple of years ago, we collaborated with the University of Iowa because of all the work that we had done in Saudi Arabia. So Saudi Arabia implemented our technology throughout the entire country. So virtually every hospital in Saudi Arabia has got Server-Side. But they had this little virus called the Middle Eastern respiratory syndrome. And so I would travel to Saudi, or I would come back from Dubai, and I'd either come into JFK or I'd come in through O'Hare, and there'd be a little placard that would warn you about MERS, so the Middle East. So we collaborated with Iowa, and so I was wrong because I came to the team and I said, hey, get ready, guys, MERS is coming over. I happen to be wrong, but where I was a little fortunate is that we have really strong data against coronavirus, which that's exactly what SARS-CoV-2 is. So really good data against MERS, we can tie that back. And so that's the kind of outcome, and those are the kind of investments that, you know, companies need to make. And I think that way we're going to stay ahead of the curve as far as, you know, again, I'm using Mother Nature, but Mother Nature is going to throw some additional curves. And I think that, you know, we should be in a pretty decent spot as far as how we can address it. Right now, the antibiotic pipeline is very thin. It's very, very thin.
And the supply chain is broken and fragile as we've experienced. So,
I mean, there's a disconnect there. You know, big pharma, you know, it's just unfortunately not a very profitable vertical. So they're not investing significantly. So governments are likely going to have to come in and provide some type of support. But we're going to have to ramp up what we're doing with the antibiotic pipeline. But keep in mind, those are antibiotics, so that's pretty good against the spore and the vegetative bugs. That's not going to do anything for us, you know, against SARS-CoV-2. So It's going to be kind of an interesting ride here.
So what do you think, Jeremy? Like, what is your perspective on the future applications of UVC? What's coming down the pipeline?
So there's a lot of great companies out there doing UVC. Not a lot of great. There's some great companies doing UVC technologies. I'm a relatively newcomer to the space. As I mentioned, I've been a medical device guy. And so there's a lot of experienced folks. I think the exposure to the fact that UVC is an effective means of inactivating pathogens will generate interest in developing a better technology. I do think we need a better understanding of, you know, what are the different wavelengths that are effective against what pathogens. There's some talk of, you know, a wavelength of 222 being effective in pathogen activation and not causing, you know, damage to somebody's skin or their eyes. That will take a long time to prove out, but that's a promising situation. So who knows? Maybe that emerges. We still don't know how that fits in because I don't think we have a good idea of the exact dosage needed and the time that it takes and the environment that it takes. So I'd love to hear from people from the 222 world. If you want to reach out to me anytime, I'd love to learn more. But I think that the applications are going to broaden. I think there's just going to be a recognition from the market that even in the FDA classifies medical equipment as non-critical medical equipment. And they're like, oh, just use a low-level disinfectant that just kills a couple of pathogens. Well, is that enough? I just think the recognition that all surfaces matter, to Gunner's point, especially the high-touch surfaces, which is my point. I think that the recognition will drive innovation. I think there's great companies working at it in the UVC world. There's a lot of UVC industry vets that have been in water and air handling that are bringing new technologies. I do think that there's a great opportunity in the operating room environment for the medical equipment that's rolling in and out. You think about, let's call it the environment of portable medical equipment, which is what we're focused on. And I'll give you the ICU as an example. The ICU is one of the most controlled areas in a hospital. An ICU patient's room is meticulously cleaned and disinfected daily. You go out into the ICU common area, it's a little less, let's call it disinfected. You go outside the walls of the ICU, and it's even a tougher environment. Yet, on a day-to-day basis, diagnostic and interventional equipment are being rolled into the ICU patient's room. Going bedside, that's the most immunocompromised patient. We know this portable medical equipment has pathogens on it when you culture it. So what are you doing to protect the most immunocompromised? I think that's where we'll see a lot of the UVC technology migrating to, is where's the most risk? What's the most difficult thing? What's the most difficult challenge? And then I think that you'll see a real advancement in good guidelines around protocol management. When are you doing your disinfecting cycle? How are you monitoring that? What healthcare workers are responsible for that? I'll give us one plug. We got a full protocol management tool with our technology. So we're trying to be ahead of that curve. And I know some of the other tower companies also have some protocol management platforms also. Awareness is just going to be bring about new innovations and better processes.
And maybe a good tie into that, Hank, is I just happen to notice one of the questions here by Frank Laspada there. He's talking about radiology. I think that leading companies, so Surfacide happened to put together a teaming agreement with Canon Med, and that's in those CT suites. And I really have to take my hat off to Canon, because they recognize that, as you're bringing in these presumptively positive patients with COVID-19, and they're going in and they're doing scans, for, lung infiltrates. Well, now, the next guy coming into this medical equipment that previously may not have even really been contemplated as a fomite for disease transmission, leading companies are really stepping up. So, Jeremy's technology, taking or addressing, a lot of those med devices, and then, really, really big, so O-arms, C-arms, and those types of things, the same kind of thing. I think that you're going to see an evolution where companies are recognizing that it is their device itself that is a fomite and could contribute to those infections. And whether that's SARS-CoV-2 or whether that's MRSA or whether it's carbapenem-resistant, Enterobacteriaceae, the whole gamut, the world has changed. And I think that it's going to take leading companies to really step up and say, hey, we get it. Our stuff may be contributing to this. What can we do with the little guys like Gunnar, to collaborate and create a safer environment for the patients, the healthcare workers, et cetera, et cetera, et cetera.
That's a great point, Gunnar. And I think I agree with you. That's going to work into material compatibility and design and all those topics that we covered. So to start closing us out here, I've got a question that I want to spend a couple of minutes on at least. And it's the regulatory landscape out there. And we've addressed it, a couple of times here and there. But anytime you talk about healthcare in particular, and definitely as you move, closer to surgery and into medical devices, et cetera, the question of regulation comes up. And, I asked earlier about the dosing requirements, if there's any oversight over that. But broadly, where do you see regulation going for this industry? And in particular, what's your personal perspectives on where you would want to see it go to best protect the patient at the end, or the consumer at the end of all of these UV treatments? And I'll start off with you, Jeremy.
Yeah, so I think serious companies in the UVC space will not be afraid of this world. As I mentioned, the first step of this was taken, not the first step, it's been talked about for a while, but the International Ultraviolet Light Association is trying to be on the forefront of this. I think the UVC industry needs to come together. We need to have an open and an excellent dialogue with the EPA and the FDA to find out what is reasonable from a let's call it from a regulatory standards environment. And then serious companies need to do it, because when those claims, if we get better involvement with the EPA and better involvement with the FDA, then you'll know as a community, either healthcare or outside of healthcare, that the claims that are being made are accurate. And that is what's needed. But we need to be reasonable. Do you need 6 log reduction of a pathogen on a wheelchair handle to make it safer? No, you don't. You need a good log reduction. Do you need to be able to kill something underneath, a wheelchair at a 6 log reduction? I don't think so, but we would need to make it safer. And if we can figure out good regulatory guidelines, we adhere to those, we make claims around those, innovation can be then developed around those. The challenges with the UVC world right now is you do have UVC companies that are challenged on exactly what to test and how to test. And we need to have more guidance and collaboration with the EPA and FDA. And I think that started with the help of the IUVA and NIST. And I hope that it continues. And I think it is coming. What it looks like is still to be found out.
All right, Gunnar, what say you?
I agree. Regulation is a good thing, and maybe let me tie this to kind of a very real world example right now. Early in the pandemic, when we had the significant challenge and shortage to PPE, the FDA came out with an emergency authorization. So there was a lot of use of UVC specifically, to reprocess the N95 masks. And Surfacide was active in this and was collaborating with some of the scientists. And, we had identified that we wanted to deliver 1 joule. So that's 1,000 millijoules, 1 joule. And then I saw some posting on social media, I think it was on LinkedIn, where I saw some first generation antiquated devices where they brought in a UVC device, and they had, Hank, I'm not kidding you, hundreds and hundreds and hundreds of masks lining a room the size of the room that I'm in right now. And they were talking about a 5-minute cycle. And where I fell out of my chair is I thought, the poor healthcare worker. That healthcare worker is bringing that mask in for reprocessing, thinking that it will be safe for future use. And I saw it, and there's no simple way that it was being effectively decontaminated. And that's where regulation comes in. Regulation makes sure that if Jeremy's making a claim or if Gunnar's making a claim, it's based on science. And so we need to collaborate with the agencies to try to identify exactly what is needed. But one of my greatest fears right now is that everything in the world right now, it seems like all the world's problems are going to be solved by UVC. And we're pretty close to it. But every single day, there's a new market entrant. And that new market entrant has got the most grandiose claims. It is the greatest thing next to sliced bread. And I'm an evidence-based medicine guy. And I'll put words in Jeremy's mouth because I know Jeremy, he's an evidence-based medicine guy. We need hard data, hard science to support exactly what is being claimed, and then let the chips fall. But then that protects the consumer, that protects the patient, that protects the healthcare worker, that protects the housewife or house husband that's going to go on Amazon and buy that device for $100 because the claims have to match up. And so for those of you that are, attending this, I guess, and I know we're pushing the time here, that's what I would encourage. Trust the data, trust the data. And if it sounds too good to be true, it's too good to be true. And make sure we're taking care of our healthcare workers, because some of the stuff that's going on out there is just wrong. It really tugs at my heartstrings because I want to make a difference and I would like to step up and say something, but it's not my place to call that hospital CEO to say that the process that you have in place is fatally flawed. But if we had regulation, that process would not be taking place.
Well, that's a fantastic segue back to the beginning of this panel, which is Why talk about UVC? Well, because we got folks out there that are making decisions, just like you said, that impact not only patient care, but healthcare provider care. And that at the beginning of the pandemic, that was one of the scariest things about all of this is what do we do if all of our doctors go down, right? If they all get corona and all the healthcare providers get corona, we're in big problem, and that goes into the PPE piece, right? And so that's that's a great reason again to thank you both for coming on the panel to help educate our audience and engage these questions. I know we barely scratched the surface of this topic, and pun intended, but hopefully we penetrated enough to do some decent disinfection here. One or two longs at least. We'll see. There was I got a couple of housekeeping notes here. There was a CE code word that came by the screen toward 3/4 in to this panel discussion. So if you're going to be watching this for CE credit for sterile processing, go back and check out that keyword. We'll have a quiz available here soon that you can go on and get your CE credit for tuning into this. I actually got one more question for you, Jeremy. It came through here at the beginning, and then we'll close this out. Let me see here.
Make it a tough one, Hank. I'm ready.
All right. So this is from Ryan. Can you disinfect my beard? Is the question.
Thanks for the question, Ryan. I think if we applied maximum dose over a 5-minute period, I think we'd probably reach about 1 joule.
Okay, just 5 minutes, huh? That's pretty. That's good. What about you, Gunnar? Like, could I triangulate the beard here and get some progress?
Going on, man. It looks pretty good. That's the real.
Okay.
Hank, I'm gonna have to work on mine after joining you for this panel.
There you go. Some beard envy going on. I get it all the time. I understand.
And clearly, I need to update my photo that you put up in.
Right. I actually thought about doing some side-by-sides for LinkedIn, and let's see if these guys, look how they look on LinkedIn. That's always the challenge. But no, seriously, thank you both for giving up your time today and educating the audience. I'm looking forward to continuing these conversations, and hopefully, be in touch. Before we turn this off, would each of you mind giving your contact info for folks who may have tuned in who have additional questions? Gunnar, if you go first.
Yeah, sure thing. So, sorry to interrupt you there, but
sure.
That's the joy of a Zoom meeting like this, right? But hey, really appreciate the opportunity and the collaboration. So you have a fair number of people. Anybody that's out there, I see a ton of people on LinkedIn. Go ahead and send me a connection. I'd love to connect with you. So go ahead and do that. If you guys wanted to send us, send me an email or for some sidebar conversation, it's just my first name, Gunner, Gunner, @surfacide.com. So again, whether it's LinkedIn, I'm a little bit in Facebook. I'm probably not as good at Facebook as I should be, but you can try to connect with me on there as well. But I would love to continue the conversation for those of you that wanted to have a sidebar discussion.
Awesome.
Yeah, Hank, thank you again for inviting me to the panel. You can, of course, connect with me on LinkedIn, send me a message, connect directly. My email is simply jeremys@uvconcepts.com. Or you can call the number that is on our website. So feel free to reach out with questions and any additional follow-up that you need. Thank you.
All right. Well, that is going to be it for the panel discussion for today. I want to thank everyone again for tuning in throughout the show. And I want to thank our panelists one last time for presenting this great education. And we'll see you again next week. Until then, keep fighting dirty.
Thanks, Hank.